So first of all, what is a class? A class is a collection of related data and function under a single name. So let me paste you this definition and once again go through the definition of a class. A class is a collection of related data and function under a single name. So for example, a C++ program can contain hundreds and hundreds of functions and thousands of variables. And using class, we collect same kind of functions and data, and we use this collection in single class. So for example, you have a book class. You can collect functions related to book. For example, print book, open book, close book, and variables related to book class. For example, you have author of the book, name of the book, and how many number of pages book contains. So this kind of data which is same or related to one another, we encapsulate this kind of functions or with this kind of variable in a single class. The second example can be a box class which can contain the height, width and the length of the box, and it can contain functions like the volume of the box or the surface area of the box. Okay, so using class we collect related data and function in C++. Now let me give you an example how you can declare a class in C++. You can declare a class in C++ using the name class itself, and then you give the name to your class. Generally, it's a good practice to start your class name with a capital letter. So, for example, I want to make a class called book. So I will write this class as books, and then you give these parentheses and this semicolon. Okay, so this is a basic definition of class, and inside your class you can declare different variables or different functions. Okay, now there is a word called access specifier. Now for example, if you want to use variables or function which you declare inside this class uh, in your main program, so the functions in book class you want to use it in your main program, you use public access specifier. Or otherwise, if you don't want to use your function inside your class and you just want to use your function inside your class itself, then you need to use private access specifier. But this I will explain you later. Right now we are going to use a public access specifier, so you can declare this public access specifier like this. Just write the name public and then give this colon, not this but this colon, and whatever you write under this will be considered or will be treated as public members of this class. For example, I declare a variable int and I will say the book ID. So I will declare it book ID is equal to 256 for example, and I will declare a function also inside this class to print the book ID. So I will say void print book ID, and I will give this parenthesis, and inside this I will just print the book ID. So I will say cout the book ID is equal to and then I will just copy this book ID, paste it here, and line. Okay. Now I have declared a variable inside my book class, and I have declared a function inside my book class. So you can declare variables and functions inside your book class or inside your any class, right? Now, for example, you want to use these members or this function in here inside your main function. What you need to do is you need to declare an object of this class. And why do we use object? Because there can be many classes inside your program, and there can be functions which have the same name. For example, the other class can also contain print book ID. The other class can also contain ID. So there can be multiple definition of these functions. And how will you know which class this function belongs to? So for this, you need to declare object, so you know which class this function belongs to. Okay, so an object is an instance of the class, right? Now, to declare the object, what you need to do is you need to use the name of the class. So I will just use the name of the class, and then you need to give the variable name or object name to this. So I will give the object name, for example, book 1 and semicolon. So this variable or this is called the object of the class, and we are going to access the functions inside this book class or variable inside this book class using this object. Okay, so how we can use this function print book ID using this book 1 object. Just write book 1, and we use this dot separator in order to access this function. So I will use this print book function and just semicolon, and then now I can just compile my program, and hopefully it will not give me any errors. So my program is built now, and now I can run my program. So I will run my program, and you can see the book ID is and whatever the ID of the book, right? So in this way you can declare objects of a class, and you can access the member of the class. These are called member function, and this is called the member variable. You can directly access this variable by, for example, you want to access this variable because this is a public uh, public variable. We have declared this in public access uh, member variable, so we can just write it here, cout book 1 dot id. Okay, and this will print you the book ID, which is 256, right? So you can access this variable also because this is a public member of this class, right? And now I will build my program and run it, and you can see it has printed 256 here. In the last video I have shown you you can use this public access specifier to access functions or variables in your main function. It works correctly, but it's not a good practice to access your member variable of a class directly in your main function, because you always want to protect your variable, and you don't want that other user would be able to change these variable content. So now in this video I'm going to show you the concept of setter and getter functions to access the variable indirectly in your main function. So I will delete this and this declaration, and I have the basic declaration of this book class, and I have the basic declaration of book object here. Now, in the last video, I've shown you how you can use this public access specifier. In this video, I'm going to show you this private access specifier, and what this private means is your whatever you declare under this private access specifier, all those member will be private to a class, and you cannot use these member variables or member functions outside your class. So I will declare a variable called string variable. So I will add one more library called include string. Okay, and this what this string class will do is it will help us to declare string variables. So there is something called string, and I will name my string as name. This will be the book name, right? And this string is just like character array, but it is handled more easily or efficiently, right? So string is nothing but just writing the book name is. You can give the value to the string like this is equal to like this. Okay, so string is nothing but the string of the word, right? Now this is our private member of this book class, and how can I access this name in my member main function, because this is a private and I cannot use this name variable outside my class. I have already told you. So let me declare the setter and getter function for it to access the name variable indirectly. So what I will do is I will declare a function called void set name, and in here I will pass this string variable, and I will call it, for example, x, right? And what I'm going to do here is I will say my name, which is my private member of a class, is equal to x. So what I'm doing is indirectly copying the whatever I will give here as a set variable. It will just copy the content of x to my name, right? And there is something called get function. So I will write get name, and this get name will return the value of name. Okay, so this will return the name. So name data type is string, so it will return string, and it's just returning this name. So just write return name. Okay, so these two are called setting and getting of your member variable, setter getter function in easy words. And what these two functions does is it enables us to access the content of your private member name using these public functions set and get names. Now I will show you how you can use the set and get names in your main function. So you already have this object called book1, which we derived from book class, right? And we can call the set function. So I will say book1 dot set name, and inside this set name we can set any name to our book. So I will say set name to the book C++ tutorials. Okay, and now I want to access. So what this does is, whenever I pass this string to this set function, it has this string here, and it just copies this string to your name variable, which is my private variable, right? Now private is assigned the value C++ tutorial indirectly, right? And now in order to get, or in order to print this value, what I can do is I can use book1 dot get name. And what this get name does is it just return the value of name. So we are indirectly accessing the value of name and returning it. So let's print this value. I will write cout, and I will just copy this function here and paste it here because it's returning the string, right? So it will return the value we have assigned here, and I will say and L, and when I compile this program, it will be compiled, and now we are going to run this program, and we see that we are able to access this name variable using this book.getName. So this is the good practice to use or to access private member variables of class using get and set functions. So just always remember this practice. Whenever you need to declare variable inside class, try making them private, right? As far as possible, try always declare the member variable private, and try to access these variables using set and get class. How we can use constructor in C++, and what is a constructor? So first of all, what is a constructor? A constructor is a special member function of a class that is created when you create the object of the class. And the name of the constructor is always same as the name of the class. So that is how you can recognize constructor. So let's see how we can declare constructor in classes. But first of all, one more important information. Even if you don't declare a constructor, C++ will create a constructor for you for a class automatically. So we have written this class, there is a constructor for this class which is automatically created, even though we have not written any constructor for this class. Now let's see how we can declare constructor for a class. So I have already told you constructor has the same name as your class name. So I will just copy this, and in my public access specifier I will just write this, and I will pass no parameter inside this, and I will give these parentheses. So this is called a constructor. Okay, so it has the same name as class, and it is always initialized when you create an object. So let's verify if it's created or it's initialized when we create the object or not. So I will write some message. I will show some message. So for example, I will write we or you are in constructor. Okay, and I will write and line here. By the way, if you don't know how this class works, I have shown you the explanation of this class, book class, in the last video. So if you don't know how to declare a class, or what are these functions in this class, I have explained these things in the last two videos. Okay, so what we have done is we have declared a constructor, and we are showing some value inside our constructor, or we are showing some message inside our constructor, right? Now let's create an object of a class. So you already know how to create an object of a class. You just need the name of your class, which is books, and give the variable name or object name, which is, for example, book1. Okay, and even though we are not calling any variable, we are just creating the object. And I already told you that constructor is called whenever object is created, right? So even though we are not writing anything, let's see what happens. I will just compile my program. Now I will run my program, and you see here it shows you are in constructor. That means what I'm saying is true, right? So a constructor is called whenever you declare the object of a class, and it is created automatically. Now we don't really use constructor to show some messages, right? It should have some specific use. So generally we use constructor to initialize the values of the variable in the class, right? So for example, what you want to do is you want to initialize the value of this variable called name. Okay, we already created set name and get name functions, and we need to initialize this name with some value. Or otherwise, for example, if somebody writes cout, this he calls this book1 dot get name, what will happen? Because we haven't initialized any value to the name, and we are calling this get name. What happens here is, I will just close this and I will compile this and see, let's see what happens. You see here it's showing some error because we haven't initialized any values, and this function does not matches this function. Let's just change this, and now let's compile the program once again and let's run the program. And you see here you will not be able to see any values here because we haven't assigned any values to our string variable called name. So why do we use constructor? We generally use constructor to initialize some value to the constructor. And how we can initialize the name value or initialize this variable name? You can just pass a parameter called string, because this variable is a string, right? So you can just pass string, for example, x, and what you can do is you can call this set name function here. Set name is equal to x, for example. Okay, so whenever you create an object, it will initialize, and you have to give some name to your object, and that object will go here, and then that function will assign this value to name, and indirectly you are assigning the value to name variable. Okay, so we have initialized name by initializing this constructor. Now whenever you pass some argument in the constructor like this, for example, we have initialized our constructor with this string variable, then you need to initialize your object with an argument which is string also. So I will give the name of the book C++ tutorial, for example, and now when we run the program, compile it and run it, you can see this book1.getName gives you the name of the book, right? And what we have done, we have simply initialized this value with a constructor like this. Okay, so once again, why do we use constructor? We do use constructor to initialize value, and when constructor is initialized, or when constructor is created, whenever you create the object of the function. And if you pass argument to the constructor, you need to pass the same data type argument to the constructor to initialize it like this. Okay, now one more little concept I want to show you is, for example, you want to create a different object, for example book2 object. You want to create a book2 object. We have created already book1 object, so we will create book2 object, and we initialize this with some other name. So book name will be this time, for example, Java tutorials. Okay, and once again you call this book2.getName. So what do you think what will happen? Because this is a different object and this is a different object. So one might think that whenever you create a second object of a class, it will overwrite the name you have given to the first object. But this doesn't happen. Every object you create, it has different or its own set of name, set of function. So this object will have independent this variable name, this function get name, and this function set name. And this has nothing to do with this object. This object will also has its own name, get name, and set name function. And this object will also have its own name, variable, and get and set functions. Okay, so when you compile this program, both object will be initialized and they will work fine. C++ tutorial, Java tutorial, and they are independent of each other, right? So it's just an instance of a class you are creating by object, and they are not related to each other, or they are not dependent on each other. Each object is independent of each other. I'm going to teach you about Destructor. So what are Destructor? Destructor is another special kind of class member function that is executed when an object of that class is destroyed. So you can say it's the counterpart of the constructor. So we use constructor to initialize some values, and we use destructor to destroy the object or variable when it goes out of the scope. Okay, so I have an example. By now you already know how to create a simple class. So I have created a simple class called books here, and I have a constructor, public constructor here, and it's nothing but the name same as your class name. So this is the declaration of the constructor. So let's see how we can declare a destructor first, and then I will show you how to use it. So to define a destructor, you just need to copy the class name once again and just paste it like this once again. But the destructor, it starts from this symbol called tilde. This is a small squiggly line, or I call it tilde. So this, whenever you start your member function which has the same name as class and it starts with tilde sign, it's called a destructor. And the basic use of this destructor is to destroy the object whenever it goes out of the scope. So let's see a small example. I will output something on the screen. So I will say we are in constructor and end line, and in the destructor we can say it's a destructor. Okay, so we are in destructor. Okay, and in the main function or in main I have defined an object of this class or an instance of this class. So if you have watched the last video, you already know that whenever I create any object of a class, first of all constructor is called, and once it goes out of the scope, which means once it goes at this line at the end of the main function, it doesn't I mean it's not necessary that it's has to be end of the function. Whenever your object goes out of the scope, then this destructor is called. So let's compile this program and let's see what will be the result. So it's compiling. Let's run the program, and you see here, first of all, your is called whenever you create an object of a class, and once it reaches the end of your scope, for example the end of the scope for this object is the end of this function, then this destructor is called. And whenever this destructor is called, all the resources which are contained by this book object are released, or all the memory which is held by this object is released. Okay, so it's a destructor is used to release all the resources which are used by the object. Okay, and in between this constructor and destructor you can do your basic basic programming, for example printing some something or some useful work. Okay, so it will start with the constructor, do its work, and once it goes out of the scope, then it will call this. Okay, so let's see once again. Build the program, run it. You see, first of all constructor is called, then it execute the code which you write in that same scope, and whenever it goes out of the scope it called a destructor, and all the resources are released by your object whenever this destructor is called. And one more little important thing that I have also uh, told you about this in the last video, I think, that whenever you don't even declare the constructor and destructor in the class or C++ will create a constructor and destructor for you by itself. So it depends upon you if you want to use constructor and destructor for your some useful work which you want to perform with them. Otherwise your class automatically uh, has constructor and destructor by default, so you don't need to define them explicitly. But if you can perform any useful task with constructor and destructor, for example constructor you can initialize some values, or in the destructor you can want to release some resources from other variables or other classes, then you can do it with the help of destructor. How you can declare your classes in different file other than your main.cpp and use those classes from different files in your main.cpp, and why it is important and useful to define your classes in different files is because whenever you write a program, or whenever programmers write a big program which can contain hundreds of classes, and if they write each and every class on the same file, it becomes really overwhelming for the other programmers, for example the colleagues, or the uh, or the boss to read those classes in the same file. So in order to make your program readable and more accessible, we define our classes in different file, so we can find those classes really fast, and this makes your program really readable and understandable. So let's see how we can create files for the class, and then we will see how we can use this class in our main.cpp. So if you are using code blocks or any good IDE, it has a mechanism of making those class files for you. So for example, this tutorial series I'm doing on code blocks, in here you need to go to file, new, and you will see the option class here. In every good IDE you will be able to find this option class, and in here you can define the name of the class. So for example, I want to make the book class, so I will say books, and here you can provide other options, like if you want to have destructor, or if you want to have virtual destructor, which I haven't taught you yet. So I will just uncheck everything because I would like to write my code by myself and not by this wizard. So I will just use this wizard to make the class, and everything else we are going to do by ourselves. So it will be easier to remember things. Now the second thing is you need to do is, if by default this checkbox is unchecked, which is header and implementation file shall be in same folder, just check this checkbox. And what this mean is you want to create this class files in your project folder. For example, I have my project folder here, and this project folder contains the main.cpp and this project file, and I want this class file also in the same folder. Okay, so this checkboxes does that, and then just click create and just say yes, and you can say yes. Okay, and as soon as you do that, just go to your project file once again, and you see here there are two new files generated here. One is called book.cpp and one is books.h, and you will be able to see them here also, book.h and book.cpp. Okay, before explaining these classes to you and header files to you, I would like to compile my program. So I will compile this, and in code blocks, whenever you create this class by this wizard, and whenever you compile it, it will give you this error. I am getting this error. If you are, in case you are getting this error, which is undefined reference to win main at the rate 16, then what you need to do, you just need to close this your project. So I will just close my project and I will save all my changes, and I will once again open code blocks, and then this problem will be solved. So I will reopen my project once again, and once again I compile this, and you see there are no errors now. So I don't know if it's a bug or what, but this is the solution I found for this problem. Okay, once this is done, you have your book.cpp file. So how you can open these files, just right click and just say open books.h or books.cpp. Okay, so we have two files here. This code block wizard has created two files for us. One is called books.h, which is called header file, and one other is called books.cpp, which is called source file. And we haven't seen this declaration of classes. So what header file is doing here is it contains the declaration or prototyping of your class or your method. So whatever declaration of the class you want to do, you will do in this header file or books.h file. Okay, and this source file will contain the definition of those member functions or those classes. So here you will write the method definition. So I think in the earlier videos I have explained you what is not member function, but what is function prototyping. What you do in function prototyping, you just make a prototype of function at the top of or above your main function, and you can define the definition of the function below your main function. So this above which you define is called the prototyping. Same this header file is doing. It's only containing the prototypes, and this will contain all of your code for your function. So let's see what is this class containing. This code I will explain you later, so just leave it as it is for now. But this is the class definition, and we know that this is how you declare the class, and it has three preprocessor directives, or this public, protected, and private. And this I will explain you later in later videos, but we have learned how we can use public access specifier, right? So I will use only public, and this is constructor if you have followed my last video. So let's define some member variable in this public domain. So I will define int book ID, for example. So I will say book ID, and I want to define the getter and setter function for this book ID. I've also explained you this getter and setter functions in the previous videos, if you remember. So I will define first of all set. So set book ID, and what it takes, it is initialized by void, so we are not returning anything, and it takes an argument which is same as book ID. So I will say book ID but with an underscore, so we know that this is the argument and this is our member variable. In a similar way, I will define a getter. So I will say int getter returns the type which we want to return. So we have book and it has a type or data type int, so we are returning int. And I will say get book ID. Okay, and it doesn't take any parameter. So this is called the prototyping of the function, right? And in header file we do the prototyping of these functions, and the definition or the source code of these function will come in this book.cpp in here. Now before moving further, you might be wondering what is this, why it's written here book colon colon books. So this double colon is called binary scope resolution operator, And why we are using this binary scope resolution operator? Because you can define different classes which can have the same function, set id and get book id, set book id and get book id. So how you will recognize that this set book id is a part of this class? So you use the name of the class colon colon the member function. So this is the constructor, which is this one, and first one is the class name. So class name and the member function, and this is books because this is the constructor, and this is also a member function of your class, right? So same thing we do with our set book id and get book id. So just remember this double colon is called binary scope resolution operator. Okay, I will copy this, and this comes just after or just before the name of your function. So this is the name of your function. Just before the name of your function, you use this name of the class, and then this binary scope resolution operator, and then name of the function. Now you can easily say that this function is a member function of this book class, right? That's why we are using this. And same we will do with this get book id. But this is our cpp file, so we need to define these function, or we need to write the source code for set book id and get book id, right? So in setter function, what we do, we just take our argument here, and we will just pass it to our member variable. So I will just do this equal to this. Okay, and what getter does, it only returns your member variable, which is this one. So you can write return book id. Okay, so this, you know how to declare or define member functions. Now whenever you see this main.cpp, you see here we have defined these files here. So it has include this iostream and include this string and using namespace std. So what you need to do is, you need to copy this all these inclusions and paste it in your header file also, so that your uh, header file or class will also know that if you use string or iostream or standard namespace, your this member variable doesn't get confused that where this comes from. So you need to include these includes, iostreams, and whatever files or headers you are including in the main file, you need to include it in the header file also. And if you see in the books.cpp, it's including books.h, which is this header file. So your source file will always initialized by this inclusion of your header file. And why we are including this? We are including this to tell your source file, which is your book.cpp, that we have declared the prototype of this class in the header file. So include all the classes or the declaration from the header file in the cpp file. So this line will include your classes or whatever declaration you have done in the header file. Now your cpp file will know that yes, I will see this declaration here, and yes, I can then uh, give the source code for these member functions here. So always include this in the cpp file. So you are including this in the cpp file, books.cpp file. You need to include this, just copy this in your main file in order to call this class in your main.cpp. Okay, so just include this book.header file in your main.cpp. Now your main.cpp knows that there is some header file, and it will go to this header file and it will see there is a class declaration there. So now it knows that there exists a class in this header file which I can use. Okay, now everything is simple. Whatever you can make the object of the class, I have already told you how to use classes. So just copy the name of the class, go to your main function, and we will define the object of the class books. And for example, book 1, so this is the object declaration, and then we can use this object to call our function member functions of the class. So first, book dot, I will call this set book id. So this will set the book id, and this will take some arguments. So I want to set book id is equal to 100, for example, and I will use get book id to print this id of the book, right? So I will write cout, and then I will write book 1 dot get book id. So this will return you the book id, right? And then once again end line. Okay, so this will return you 100 because we have set the value of book id is equal to 100, and we are getting this here and printing it. So let's compile our code, and it's compiled successfully, and when I run this program you will see 100 here. Okay, so now you can declare your classes in this form of source file and header file, and use these classes in your main.cpp file, so that it's easier to see and you understand that you have these class declaration here, and you can use these classes here. So this makes your code really simple in terms of understanding, and in a long run, when you have 10 or 50 classes, it will make your programming really easy when you define these classes in different header files and source files. So I'm going to teach you about arrow member selection operator. So in the last video I have shown you how you can create a class in other files other than your main.cpp. So we have created a class using this source file or .cpp file and header file. So if you haven't seen that video, just watch it so you know how you can create your file in the separate file, or how you can create a class in a separate file other than your main.cpp. So I'm going to use this class example which I have shown in the last video, and I will demonstrate how this arrow member selection operator works. So in this header book.header or book.h file which I have made in the last video, I have defined the class prototype, and I have declared a book class, and in this we have public members, which is public member variable book id, and we have created getter and setter of this book id variable. So getter method and setter method of this book id, right? So our header file contains the prototype of a class and member functions, and our source file will contain the source code of these prototype which are here. And how it knows, how your CPP file knows, by including this header file in your CPP file, it knows there is a class which exists in book.header. And I have written the source for this setter and getter method in this .cpu file, which is just uh, setting the value and getting the value, which you know by now already. I have already explained how to define setter and getter method in C++ in the earlier videos. So this is this class is doing. It has one member variable and one setter function and one getter function for this member variable, right? And the definition or the source for these member functions for setter book id and get book id is here, and this I have explained you in the last video. And I have already also explained you in the last video how you can create an object of the class, for example book class, and how you can call this method or member functions from the class using this object. Okay, so we have called set book id and get book id from the book class. Now you can also say that this book class is your user defined data type. So we have seen we can create string, for example string some value, and this we call it as a data type, and this we call it as a value, right? So we can also say that this book is our book data type, right, which we have created. So it's a user defined data type, and this is a variable in other words, right? And we can use the concept of pointer, which I have explained you in the earlier videos, and we can use the address of this object to access our member functions from the class. So how we can do it? We can define a books pointer, for example. So I will say first of all this asterisk and then book pointer. And what this book pointer does, or what is a pointer? A pointer is a variable whose value is the address of another variable, right? If you remember. So I want to give the value of this pointer as an address of this book class. So I will write equal to, and we give address by this and sign, and address of book class. So we have created a pointer of type book. Okay, and by using this pointer we can access these set and get method, like we have seen in the case of book one. So when we created book one, we can use dot separator to access these member variables. But whenever you use pointer, what you need to do, either you can do it like this. So you just copy this pointer of type book and give this bracket and paste this pointer inside this, and then write dot your whatever member variable you want to call. So I call set book id, and I set it 300, for example. Okay, and I want to print this. So once again I will just copy this whole pointer dot the get book id or the member variable. So either you can use this kind of definition to call member variables, and I compile this program and I will run this program. So let's run it, and it says 100 and 300. So it's working fine. Our pointer of book type is working fine. But there is a better way of doing this, which we are doing. It looks a little bit weird or ugly when we see it. So what we can do, instead of doing the pointer in the brackets dot the member function, instead of this I can just copy my pointer, which is book pointer, and I will give arrow like this, and this arrow is called the arrow member selection operator, and the function of this is same as this dot separator, but whenever you use arrow, your C++ program knows that this is a pointer. So whenever you use pointer, you separate it, or you can access your member variable by using these arrow access or arrow member selection operator, right? And I can do the same here. So I will call this select or set book ID here, and this time I will set book ID 1000, for example, and I will call this C out here, and I can once again use this arrow separator or arrow member selection operator to call my get function also, or get book ID also, and this looks much better. You don't need to write this all, even though this is also valid in this case, but this looks much better, and by seeing this arrow separator you can say that this variable or this object is our pointer of this type or whatever type you define, and this will work same as this code. So let's try to compile the program and run the program, and you see here we can see 1000 this time. So you can define the pointer of a class, and using this pointer of a class you can access the member variable of a class either like this or using this arrow member selection operator. Okay. Hello guys, in this video I'm going to teach you about operator overloading in C++. So we all know that C++ has some operators which we can use to perform some algorithmic task, or you can perform some comparison task from these operators. So for example, we have some of these kind of operator which you can see here. So we have this plus operator, equal to operator, minus or asterisk, or this backslash, percentage, and we also have these comparison operators in C++. And by these operator we can use these operator to for example, we can use this plus operator to add two integer values or two double values or two float values, right? So we can use it like this. We have two integer, for example x and y. We can use this plus operator to add these x and y and store it into this z variable, and this is also a equal to operator, and equal to operator we use it for assigning the value. So these are the some of the inherent properties of these operators. So C++ has defined that we can use plus to add two values or equal to assign the values. But for example, we have some values, or we have some object which we want to add, for example. So for example, I have this class called vector, and I want to add the two object of this class. Okay, so I will define two vectors like this: vector1, which has object vec1, and second class object vec2, and I want to add these vec1 and vec2 and assign it in the third vector called vec3. Is it possible using C++? Well, when I compile it and when I see it, it will give me an error, because C++ doesn't know that there is a class called vector. So C++ libraries doesn't have these this class is user defined class, right? So it doesn't know if we use plus, it has to add these two object of the class. Okay, so we can use a concept called operator overloading, and it's same as method overloading. What is method overloading? We can define two functions of same name, and these two functions can perform two different tasks, but they can have the same name, and this is called function overloading. In the same way, we can use operator overloading to perform the same or perform two different tasks from a same operator. For example, I want to add these two objects. I can do this whenever I I define a operator which can be overloaded. So let's see how we can do this. So for example, I want to add two vector values which are the Cartesian values, and I will give you an example. So for example, I want to add these two Cartesian values, for example 4 comma 2 and 2 comma 2. I can do it in mathematics. It's done by like this. So 4 plus 2, which is 4 plus 2 is equal to 6, right? And this y 2 plus 2, here 2 plus 2 is equal to 4. So I want to add these two Cartesian value using a class, and I want to use plus operator for that, and I want the result like this. Can we do this? Let's see if we can do this by operator overloading. We can certainly do that by operator overloading. So let's see. I have defined this class called vector. It has two public member variable which are integer x and y, and I have this default constructor which doesn't take any values in it. Okay, so what I'm going to do is I am going to define one more constructor. So I will overload this constructor. So this is the default constructor, and I will overload this constructor. This is the same concept as function overloading, right? So we can use the same constructor of same name to perform two different tasks, and I can write int a comma int b. So what it's doing, it is I am initializing this vector constructor by two values a and b, and these two a and b, the value of a and b, I will assign to x and y. So x is equal to a and y is equal to b. Okay, so this is simply doing this. Okay, and now how we can define operator overloading. So whenever you want to define operator overloading, what you need to do is, first of all, you need to make a prototype of this. And operator overloading returns, when you define operator overloading, it returns the same class as your class. So we are in vector class, so it will return operator vector, right? And then we specify that we want to do operator overloading by the keyword called operator, and then just after this operator keyword we need to give the operator for which you want to overload this. So for example, we want to overload plus operator. Okay, and we want to add these two Cartesian values with this plus operator. So I will use plus. You can use some other operators like minus here, or this percentage here, or any other operator which you can see here, or any other operator which exists in C++. You can use all these operators instead of this plus, which I'm using in this case. Okay, and then I will pass argument here, which will be the class. Okay, so I will write const and the class object. So I will just copy the name of the class, and I will use this address of the class. Okay, so this is the prototype of operator. So we want to overload plus, right? Now in order to define or write the source for this operator, what we can do, we can just we also need okay, we can just copy this prototype from here, and just outside your class we can define this here, right? So I will just copy this and paste it here, and I will write definition of this function or operator. Okay, and because I've already told you in the last video, we need to give the scope for this operator, right? So we need to give this class of the operator in which class exists, and then these two double colon which are scope resolution operators, right? So now you know that this, by seeing this vector colon colon, you know that this operator is a part of this class, which is a vector class. Okay, now we can write the definition of in this vector function. So I will copy the same class here, and I will name it as temp. So I created a temp object of this class, and what I want to do, I want to do the addition of the two vectors using this. So I will use temp dot x, this one, which is a member variable of the class, is equal to x plus temp or param, which I have to pass here, param parameter. Okay, so which whatever parameter we will pass, which will be object or an object of this vector, we can use it like this, dot x. Okay, so what this is doing, this is also an object of class vector, and this is also an object of class vector, right? And whatever we pass here, we want to add it to our temporary object, which is this one. Okay, similarly I want to do the same for the y variable, y member variable. So I will do y, y and y, because we have two coordinates, right? And what I want to do next, because this is expecting the vector object return, I will return this temp like this. So return temp like this. Okay, so what this code will do, it will just add the parameter which you pass here to the temp, and it will return. Okay, and this operator will addition operator will be overloaded by this one. Okay, now how to use this in the class? So in the same way, I can define two objects of a vector class. So vec1, and I'm going to use this constructor which takes two integer values. Okay, so I will pass two integer values. I will pass first coordinate here, so 4 comma 2 here. Okay, 4 comma 2. So I will pass 4 comma 2, and I will make second vector, and I will pass my second value here. So vector 2, and my second value is 2 comma 2, for example, right? And I can add these two values in a third vector. So I will say vector result, and I can add these two vectors like this. Result is equal to vec1 plus vec2. Okay, and this will now not give you an error because we already told our C++ libraries that there exists a plus operator which is able to add two classes or two objects of the class vector. Okay, now we can display the result, for example, like this: cout, and how we want to display the result. Let's see, cout, and we can say in double quotes the result is, and in the bracket we want to give first of all the x, so I will say result dot x. Okay, and then I want to give the comma, so I will give this once again, and double quotes I will say comma, and then the value of y. Okay, so result dot y. Okay, so now result dot x and result dot y will contain the addition of these two, 6 comma 4 in our case. Okay, and then once again I will use this bracket to close it, and I will use end L to end the line. And first of all, we forgot this. Okay, so now this will show the result like this. Let's try to compile and check whether it's okay or not. So this is showing the error. Let's see what's the error is. Okay, so this spelling of const is wrong. It should be like this. I will explain you what this const mean, what is the purpose of using this const, but for now just uh, take it as it is. Okay, I will now recompile my program once again, and yeah, same spelling once again. Okay, so our program runs successfully or compiled successfully, and let's try to run this. And you see the result is 6 comma 4. So we have successfully added two vector object using this plus operator in C++. Okay, so in the same way you can subtract, or you can use all the operators which you have in C++ to overload. You can overload equal to or double equal to or asterisk or whatever we have in C++, we can overload. Okay.
Hello guys, in this video I'm going to show you what is inheritance and how to use inheritance in C++. So we all know that C++ is an object-oriented programming language, right? And inheritance is one of the most important concept of object-oriented programming. So what inheritance does? Inheritance allows us to define a class in terms of another class, right? So once again, inheritance allows us to define a class in terms of another class, which makes us easier, or which makes it easier to create and maintain our application. And this in result will increase the reusability of code and faster implementation of our code. So let me give you an example. For example, you want to calculate the area of some shapes, and this shape is a polygon, right? So what polygon can be? Polygon can be a rectangle, polygon can be a square, polygon can be even triangle, right? And why I'm saying this is because each of the polygon has similar property. And what is the property? Every polygon, rectangle or square or triangle, have height and width. Okay, so height and width are common to each polygon, but the calculation of area for each of the polygon is different, right? So what we can do is we can define a class which have width and height that we can reuse in other class, for example rectangle, square, triangle, or any other variable, so that it will reduce our code writing also, and it will use the reusability of our width and height in our polygon class. So let's see how we can define uh, inheritance classes in C++. So I have already told you we have polygon class, and in this class, for example, I named this class as shape. Okay, and this class has two member variables, width and height, as I have told you. And what are these? These are protected members. Now I think I haven't discussed about protected access modifier before, so this is the right time, I think. So protected member of a class are reusable or can be used in other class which is inheriting this class. Okay, so I'm going to give you once I complete this example, you will be able to understand what is protected, and I will repeat this definition once again. And you already know what is public members. Public members are available in other classes freely, even though they are not inheriting from the base class. So we have our class which we call as base class, which will be a base class for rectangle, square, or triangle classes, and the height and width we want to keep common to this rectangle, square, or triangle class. So we have the class called shape, which has protected members, which is height and width, and which has public function which sets these the value of width and height. Okay, so this is a simple function which takes two arguments, and whatever argument we pass it in this function, it will set the value of these two, width and height, right? So this shape is a base class. Now for example, I define a class called rectangle, uh, this little bit, okay, so rectangle, and in this rectangle we want to calculate the area of the rectangle. Okay, so this has public function called void area, and what it does, it's just we are using to calculate the area of the rectangle, right? So what we are going to do, we are going to use these width and height from the shape class to our rectangle class. And how we can use it? By using inheritance. And how we can inherit from our shape class to our rectangle class. Okay, so the shape class in our case is called a base class, and rectangle class is in our case is called the derived class. And how we can inherit from this shape class, inherit these member variables or member functions in the derived class, we just use a colon, this kind of colon, and then we define a access modifier which is public public, and then the name of our class from which we are deriving. Okay, so this kind of declaration is called inheriting from the base class to the derived class, and rectangle in this case is called the derived class, and shape in this case is called the base class from which we are inheriting. And what we are inheriting? We are inheriting height and width of the polygon. Okay, so we have the function, public function, and we want to calculate the area, right? So what we can do, because we are inheriting from the shape class which have height and width defined already, we can use all the public and protected members of the base class in our derived class. We can use this height and width in our derived class. So what we can do, return what is the area of the rectangle, height into width. And because we are inheriting from shape class and these are the member variable of shape class, we can use it here also, height multiplied by width. Okay, so inheritance allows us to reuse the base class member variable which are either protected or public. Okay, and it will give you the area of the rectangle, right? Now in order to calculate the area, let's define another class, for example triangle, and this also will inherit from the shape class, and we also want to calculate the area of the triangle. So this is a class, second class, which is inheriting from the shape class, and in this class also we want to calculate the area of the rectangle, triangle, right? And the area of triangle is height into width divided by 2, right? If you all agree with me, I think. So area of the triangle is width into height divided by 2, right? So what we are doing, we are reusing the variables from our base class in our derived classes, which are rectangle and triangle. Now we can just define the object of our rectangle class. Rectangle is equal to rectangle rec. Okay, and we can define the object of triangle class, triangle tri, for example. And what we can do is we can reuse, or we can use the function which is set value, which is there in the shape class, by using these objects called rectangle or triangle, because we are inheriting from our shape class, right? So once we write rect, which is an object of rectangle class, dot, and you can see here set values is available here, right? So we are going to use this, and we can set, for example, we want to calculate the area, width is equal to 15 and the height is equal to 10. Okay, so this will give you the width and height. With this will set the width and height. And I forgot one thing, because we are returning this, we need to return int instead of void, right? You may be confused why I'm writing void here. It should be int because we are returning integer value, right? In a similar way, I can use triangle object to calculate the area of the triangle, and the member function set value is also available here. For example, the same values I want to give in the case of this triangle to calculate the area of triangle. So this set function is there in our base class, but we can reuse this in our derived class using the object of our derived classes, right? Now to calculate the area, I can just write std, not here, but here, standard, which is standard, cout, and then we can just print area rectangle is equal to, so the area of rectangle we can find it from this rectangle function, which is a area function, right? Area. So we can use this object of this rectangle class, right? So rec dot area, right? It will give us the area of the rectangle. Then I will just write the end line, and in a similar way I can find the area of the triangle, area triangle, okay? And this time we are going to use try object. So let's try and run the program. I will just build this, and yes, we want to build it now, and it gives some error. Let's see what is the error. Okay, so here I forgot the semicolon, here also I forgot the semicolon, and let's rebuild it once again. And still, because this has to be here. And when we will build it, we can see area rectangle is 150, which is 10 multiplied by 15, which is 150, and the area of triangle is 75, which is 15 multiplied by 10 divided by 2, which is 75. Okay, so this is the concept of inheritance. So once again, what inheritance does? Inheritance allows us to reuse our member functions or member variables from the base class, which is shape in our case, and we can inherit from shape class because what we want to reuse this height and width function in our rectangle class and triangle class or even square class, for example. And in the derived class, so class which is inheriting from our base class is called the derived class, and in this this class has the access to all the protected members and public members of the base class. So what are protected members? Protected members are the members which can be reused in the derived class. Okay, so class in which we are deriving, from which we are deriving, these are protected. But if it was a private member, height and width were the private member, we cannot use it in the derived class. Private members are private to the class. They cannot be reused outside the class. And what are the public members? Public members can be used everywhere, right? Even if this rectangle class will not be derived from the shape class, even then also we will use public members from shape class. But in order to reuse this height and width, we need to define these members as protected because we are inheriting from this and we want to reuse this height and width, right? So this is how you use protected members. Protected members are only available in the derived class and not in any other class. And public members are available in any class even though it's not inheriting any class. And private members cannot be used outside your class because they are private, right? So this is the difference between public protected and private access modifiers. And this is how you can use this inheritance. Now, how you come to know that you can use inheritance in your C++ program? So C inheritance always have the relation of is a relation. So I will write it in double quote, is a relation. Okay, and what is this is a relation? If you can find this relation, for example, rectangle is a polygon, right? Square is a polygon. Triangle is a polygon. Then you can use inheritance, right? I will give you another example. For example, we have the base class called animal, and we have derived class dog, cat, for example. So dog is an animal, right? Cat is an animal. So in this case also we can use inheritance, where our animal class will be a base class which can be reused in place of shape, and dog and cat can be used as derived class which can inherit from animal class.
And I have shown you how you can create a base class and create a derived class from which you can inherit from base class. So we have seen in the last video that our shape is our base class. I have given you an example of this polygon and types of polygon, right? And the polygon, for example, shape class was our base class, and the rectangle which was inheriting this shape class was the derived class, right? So we were just calculating the area of rectangle using the inheritance method in this example, right? If you haven't remembered this example, just watch the last video. And in this video I'm going to show you that it's not only that you can inherit from one class, it's also allowed to multiple inheritance or inherit from multiple classes in C++. So if you remember, we have created in the last video a shape class which was our base class, and the rectangle class which was our derived class. Let's create one more base class, for example class, and I will name it as description, which will give us the description of any class, right? And what I'm going to do is I'm going to create a simple program, print, and what it takes a string which gives us the description. Okay, so and what I'm going to do is I'm going to print std cout, and then I'm going to print we are using, and then I'm going to give the space, and I'm going to use this description variable which I'm passing it as an argument, and I can just say class. Okay, and I will end line. Okay, so this is a very simple class. Let me give the access modifier also. Okay, so this is a very simple base class, and what it does is it just gives us the description of whatever we pass as an argument, right? So one class which is a shape class, we have used this class in the last video as a base class, and for example we want to use this description class also as a base class for our rectangle class. So what we can do, we can multiple inherit from shape class as well as your description class. And how you can do, you can just separate your inheritance by a comma, or in base classes by a comma. So now this rectangle is um, inheriting from shape class as well as description class, but don't forget to give this access specifier to every base class here. Okay, so we are inheriting from two classes, and now in the main I have created, if you have remembered, that I have created a object called rectangle rec, and I can calculate or set the values using this set value method from our shape base class, right? So from our rectangle object, which is a object of our rectangle class, we can access the method from the base class, which was the shape class. In a similar way, we can access the method from description class from or by using the object of our rectangle class, because we are inheriting from our description class into the rectangle class also, right? So what we can do is, we can just, in the next line, we can use this rectangle class or object, and we can, whenever we just write dot separator, we can see the print method is also available, which is a method we have defined in description class, right? But because we are inheriting from description class, it's available to the object of your rectangle class also. Just use this, and you can just give a string as a parameter, and for example I can say rectangle. Okay, so we passed rectangle as a parameter. Now I'm going to run the program. I need to build it first and then run the program. Now I'm going to run this, and now you can see we are using rectangle class, right? So in this way you can inherit from multiple classes, and all the function or member variables are available for usage by the instance of the derived class also. Okay, so this is from the base class function, right? This in the last video we have seen this, we have defined in the base class. In a similar way, this print method we have defined in the base class called description. We haven't defined any print method in the rectangle class, but even then also we will be able to use this print method from the description class, because we are inheriting from the description class in the rectangle class. And whenever we inherit, the public and protected members of the base class are available for use to the derived class. Okay, hello guys, in this video I'm going to show you what are friend classes and how to use friend classes in C++. So in principle we know that we cannot use private or protected members of class outside the class. So for example, we have a class called my class, and it has a private member variable called secret. And we all know that if we declare this variable in this private, under this private access modifier, we cannot use this outside the class. Now sometimes we need to use this private members of the class in other classes, and in this case we use friend classes or friend keyword. So let me give you an example first. So we have this my class which has a private member called secret, right? Let's declare another class which I call my another class, for example, and this class wants to access the secret variable which is private. So we all know that we cannot use this, right? So for example, there is a public uh, member function in this my another class, and we can call it anything. For example, void uh, show secret. Okay, so this is a function, and let's give it an argument. So I will pass my first class here as an argument. Okay, because I want to use the secret in my second class. So, and I will call it my or MC for my class, and then I want to use this. For example, I want to use, so this is MC is the object of the class, as you all know that we can create an instance of a class. But when we want to access the secret variable, which is a private variable in my class, so when I write dot and when I write mc.secret and when I try to compile this, let's see what happens. And it gives us an error. And what is the error? So this error is within this context. So my class secret is private within this context, which is true, and which is also we know by definition that we cannot use private members of a class in another class, right? But for example, for some reason you want to use this private member in your another class. How can you do it? You just need to declare that the class in which you want to use the private member, you just need to copy the name of this class. So because my another class wants to use the private member in the first class called my class, right? So I need to declare this my another class as a friend of this my class. So what I can do? I can just write a keyword called friend and then class and then the class name for which I want to make the friend or make this friend. Okay. So if you declare in your first class that this another class, my another class is the friend of this class, then this keyword allows you to access the private member by this class. So now if you declare that my another class is a friend of my class, then my another class has the access to the private members of the class. Okay, so I'm going to build it and hopefully it will not show any error, and it doesn't show any error. Okay, so for example, I have the value for secret is equal to 10 and I want to set this value to some another value. I can set it, right? So I can do plus plus, for example, in this function, and then what I can do, I can simply call the instance of this class here, my another class, right? And I can say MAC for my another class, which is the object, and then I can declare the instance of my class, which is my first class, which is MC, for example, and then I can call this function using MAC from my another class, show secret dot show secret, right? And it takes an argument which is the instance of the class which we have this private member in, right? So just copy this instance here, and then you will be able to see the value of the secret. So for example, I can see out here, or std colon see out, and I can just print the value of this, okay, and std colon and l, okay. So now I will compile the program and then I will run the program. It compiles fine, run it, and it shows the value of the secret is 11, right? Which is true because we set the value of secret as 10 and we are increasing this to plus 1, and now the value is 11. So the basic thing is, whenever you want to use a private or protected members from one class to another class, you need to use friend keyword or friend class keyword of the class in which you want to use this private members. Okay, so for example, this is the class in which you want to use the private member of my class. Then you need to give this keyword friend class my class, so that this my class knows that my another class is a friend of this class, so I can use these private members from the other class. Okay, so this is the basic concept. Hello guys, in this video I'm going to teach you what is polymorphism and how we can use polymorphism in C++. But before that, I must recommend you that you must know the basic concept of inheritance in C++, and you must have some knowledge of pointers. So if you are following these videos, you can find the lesson on inheritance in the video number 32. So I will strongly recommend you that please watch and understand how inheritance work first and then watch this video, because polymorphism depends upon inheritance strongly. So I must recommend you to watch that video and then uh, see this video. Okay, so what is polymorphism? If we see the literal meaning of polymorphism, then polymorphism means having many forms. So typically polymorphism occurs when there is a hierarchy of classes and they are related by inheritance, right? So the polymorphism, or the property called polymorphism, we can use where we are using inheritance or classes are related by the hierarchy of inheritance. That's why I was stressing on watching the lesson on inheritance. Okay, now how we can use inheritance in C++? Not inheritance but polymorphism. So I'm going to take an example from the video number 32, in which I have shown you how inheritance works. Okay, so this was the example I have used in video number 32, and what I have done in that video, I have declared a class which was a base class, and this class I named it as shape. And what my purpose of you know creating this class was, I wanted to calculate the area of some polygons. For example, triangle or rectangle or any other polygon. Okay, and I wanted to calculate the area of those polygons using a base class, because every polygon has the property that it has height and width. Okay, and you can calculate the area of triangle, for example square, triangle or rectangle, on the basis of height and width. Okay, so I defined in that video in which I have taught you this inheritance, this class called shape, and this has a public method set values, and this has two member variables which are height and width. Okay, so if you don't remember, just watch the video on inheritance and you would know. Okay, so we have this class, and in which we have two variables, height and width, to calculate the area, and we have a member function called set values. And this member function, what it was doing, it was just setting whatever argument are passed to it to the width and height. Okay, so we have this base class. Now I have defined two derived classes which are inheriting from my shape base class. Okay, so I have defined a rectangle class which is called a derived class, and I'm inheriting from my base class which is my shape class. And what I'm doing here, I have only one member method here which calculates the area of rectangle. Okay, and how I am calculating the area of rectangle, because I am inheriting from the base class shape, the member functions, public and protected member functions, are available in this class also from the base class. That's why I will be able to use the member functions uh, just like height and width from shape in my derived class, which is a rectangle class, and I'm just multiplying this height and width to calculate the area. Okay, so this is the area of rectangle. In a similar way, I'm creating a class called triangle, and this has also one member function which is calculating the area of triangle, and the area of triangle is height into width divided by 2, right? So I will divide it by 2, and this is because we are also inheriting from shape in this triangle class also. So the member variables and member functions, public and protected member functions, are available in this triangle class also to use. Okay, so this gives the area of triangle in triangle class, and this member function area gives the area of rectangle in rectangle class. And to set the height and width, we are using this base class shape. Okay, now what I want to do is, I have already told you what is polymorphism. Polymorphism is having many forms. So what my goal is, I want to define my rectangle class and my triangle class in terms of my shape class. So what I can do, first of all, I will define the instance or object of my rectangle class, rectangle, REC, and in the same way I will define the instance of my triangle class, TRI for example. And then what I'm going to do is, I'm going to create an instance of this base class shape. Okay, and I call it poly, for example, because shape, I want to calculate the area of polygon, right? Polygon, that means rectangle or triangle. So I will name it as poly, and I will define the pointer to this object like this. If you don't know pointer, I have already shown you how to use pointers in previous videos, so you may want to uh, see those videos if you don't know about pointers. So I have defined a object which is a pointer, and which points to, this is important, which points to the address of my rectangle class. Okay, which points to the object of my rectangle class. So this is the object to the rectangle class, and when we use and, it is the address of this object. And what is a pointer? If you remember, pointer is a variable which points to the address of the another variable, and this is a rectangle variable right now. Okay, and because why we are able to do that, because there is a property in C++ that whenever you inherit from a base class to a derived class, you can define an object in terms of derived class object like this. Okay, in a similar way, I can derive a poly2. So let me name it, this is poly1 and this is poly2, and I can do the similar thing with triangle object or tri object. So what I'm doing, I'm defining a pointer which points to the address of my triangle class object, and this is really the essence of polymorphism. So what you have done, you have defined a class in terms of other class, or this poly or this shape has many forms. Once it has the rectangle form, once it has triangle forms. And what is polymorphism? Having many forms, right? I have already told you in the starting of the video. So this is solving our purpose. We can define poly object or polygon object or shape object of shape in terms of rectangle also, and in terms of triangle also, right? So then what we can do, simply we can use this poly object to set the values, for example poly. And if you remember, whenever we define a pointer to the class, we use this arrow member. So this is like this, not underscore but minus and then arrow. Okay, and we can set the values, and in this values we can define any values to calculate the area. So the height, for example, is 10 and width is 20, for example. In a similar way, when I want to set the width and height of the triangle, I can set it like this, poly 2, this should be poly 2, and then I can set it the same function I can use from my shape class to set the values. Okay, now I want to calculate the area of the both triangle and the rectangle. So what I can do, I can just simply call, so I will just see out std colon see out, and then I can call my triangle or rectangle object here dot, I can just call the area member function from my rectangle class. If you remember, this class has a function called area. So I can just directly call this area function because it's calculating the area depending upon the height and width, and height and width we have already set, so it will give the area std and line. In a similar way, I can just print the area of triangle, right? I just need to use this tri and I can calculate the area of triangle. I will build my program and I will see if it has some errors or not, and if it compiles I will run it, and you can see it gives two values, 200 which is the area of rectangle, which is 10 multiplied by 20, and 100 which is the area of triangle, which is 10 multiplied by 20 by 2. Okay, so once again, in order to use polymorphism, you have to have the hierarchy of classes in terms of inheritance. Always remember that. And whenever you want to use polymorphism, the basic definition of polymorphism is to define a class or to class which can have many forms, more than one forms, and this is doing the same. Our shape uh, instance is having rectangle form in at one place, and our shape object has triangle form at another place. So you can assign or define other polygon classes, for example square or any other polygon classes, and you can even define that polygon class if you are inheriting from the shape class in terms of the other classes also, and you can calculate area or whatever you want to calculate. So this is the basics of polymorphism in C++.
Hello guys, welcome once again. In this video I'm going to teach you what is a virtual member function and what is a pure virtual member function. But before showing you how this virtual member function and how to declare this virtual member function, I must recommend you that you must know the basic concept of polymorphism in order to understand this virtual function, because uh, this virtual member functions are generally used whenever you are using polymorphism. So I have shown you how to use polymorphism in the last video. If you don't know what is polymorphism, I have shown that in the last video, so please watch that. And I'm going to take the same example from the last video in order to demonstrate this virtual member function. So in the last video, I have defined a base class, which I call it as a shape class. And what my purpose was is I wanted to calculate the area of different shapes. So I have this base class called shape, and this was this shape class, which is my base class, have these member variable height and width, and have this member function called set values. And what this is doing, this is just doing this this is just setting the values of width and height here, right? And I've also defined a derived class which I call rectangle, and which is inheriting from this shape class, and this has only one function called area. And this, what this was doing, this was just calculating the area of the rectangle by multiplication of height and width. And if you know, when you are inheriting from a class, its member functions are available in the derived class if they are private or if they are public or protected members, right? In a similar way, I have defined this triangle class to calculate the area of triangle, and I was inheriting from my shape class, and this triangle class also had a function, member function called area, and I was calculating the area by multiplication of height and width divided by 2. And the
let's see how virtual function work. So first of all, what is a virtual member function? A virtual member function is a member function that can be redefined in the derived class. Okay, so let's see how we can define a virtual member function. Uh, One more important thing is you can define a virtual function or virtual member in your base class only. Okay, so my shape class is the base class, so I can define the virtual member function here. So how you can define, you just need to use the keyword virtual and then the normal definition of a member function. For example, I want to call my function as area, so I will just define the function called area, which takes no argument and it returns 0, for example. Okay, so this is how you can declare a virtual function. And what is the use of defining this virtual function? So if you define your member function as a virtual function in your base class, you can provide the redefinition of this function in your derived classes. So I have this virtual function called area. I can provide the redefinition of this virtual function in my rectangle class by the same name area, like this. And I can even define the same or redefinition of this function in my triangle class. By redefinition, I mean the name of the function is same or the prototype of the function is same, but the implementation is different for different classes, or the implementation is depending upon the class in which it's defined. Okay, so the prototype is same, which is int area, and the definition is different. In the case of rectangle, I was calculating just height into width, and in the case of triangle, I'm calculating the triangle area by height into width divided by 2. So the basic use of virtual function in the base class is just to tell C++ that we have defined this function as a virtual function because we want to redefine this function in my derived class, and I want to redefine the definition of this virtual function in my derived class according to the requirement of the derived classes. And this virtual member function you can use as a normal virtual function whenever you want to use it in the main class. So for example, I declare a instance of this poly. uh, by the way, this code I have written in the last video, right, if you remember. And I have defined the instances of my derived classes rectangle and triangle like this, rack and try. And this I have also defined the uh, instance of my base class, which I call it poly, right? And according to the polymorphism concept, I can point to this derived class using my base class like this. So I can define a pointer which has the reference of my derived class object. Okay. In a similar way, I have done the definition of this triangle derived class also. And in a similar way, I can point to my base class also. So this is the instance of my base class, which is pointing to the base class itself. And I can set these values which I have defined in my base class. You can see, which set the value of width and height here, and then I can calculate the area of the specific member or specific class for the specific class. So rectangle gives the area of rectangle, triangle gives the area of triangle, and poly gives the area of polygon, which I have defined. And I can compile it and I can run it, and it gives the area like this. So the area of rectangle is 200, which is 10 into 20. Rectangle area of triangle is 100, which is 10 into 20 divided by 2, and area of poly is 0 because we have defined a virtual member function which was returning 0 here, right? Now this is about virtual member function. Now what is a pure virtual member? So a pure virtual member is a member which have no definition. So right now I have defined a virtual member function like this, and this is returning 0 here. That means I have provided some definition to my function. But if you want to tell that this is a pure virtual function, you don't even provide any definition here. And how you can say that this is our pure virtual function? You just need to assign 0 to this function, and then tells this type of declaration tells C++ that this is a pure virtual member function. And what is the speciality of this pure virtual member function? The speciality is you don't even have to give the definition to this pure virtual member function in your base class. You can redefine this virtual member function in your derived classes like this. Okay, so this is a short way of telling C++ that you have this function in the base class which you want to redefine in your derived classes according to the requirement of the derived classes. So you can do it like this. This is how you can define a pure virtual member functions. Okay. Now suppose, for example, I don't give the definition here uh, of this pure virtual member function. Okay, and I don't calculate the area of this rectangle also, for example. And what I'm going to do is I'm going to compile my program. So I compile it and it gives me the error. Okay, and why it's giving me the error? Because it says cannot declare variable poly to be the abstract type shape. So this error is coming because I haven't defined or I haven't given the definition of member function or pure virtual function area in my rectangle class. So this is the restriction of pure virtual function. If you define a pure virtual function in your base class, you need to redefine the definition of this member function in your derived class, otherwise it will give the error. Okay, so I haven't redefined this area member function in my rectangle class, which is deriving from the my shape class. So this is throwing an error, or this will give the compilation error, right? So I have to give the definition of this member function, virtual member function area in my derived class, otherwise it will throw an error. So once again I will define the definition here, and once again I compile it and it will run fine, I think. Let me see. And once again it cannot declare variable poly because it's abstract type. Let's see. Yeah, so once you have this, you know, once you define your function as a pure virtual member function, it makes your class as an abstract class. And what is the abstract class? Abstract class is a normal class, but the speciality of the abstract class is it's just the definition of the class. So abstract class are something very similar to our shape class, and abstract classes are just the definition of the member function and no implementation is given here. Okay, So we haven't given any implementation of the area function, so we cannot define this object here. This is true. And once again compile it. Yeah, I need to remove this also, and this will not give me an error. Okay, so always remember that if you define your member function as a pure virtual function, this makes your base class as an abstract class, and abstract class is a class which have only the definition. Okay, so not the definition but the prototyping definition you provide in the derived classes. Okay, so notice that our area here has no definition. Okay,